Welcome to the video lecture Digital Principles and System Design. In this video lecture we are going to see the topic read-only memory in Unit 5 Memory and Programmable Logic Devices. This unit has two course outcomes. First half is basic memory structure and in that we are going to see the types of memory, ROM and RAM and their types. Second half that is second outcome is from implementation of combinational logic circuits using PLA and PAL. In previous video lecture I have explained RAM, static and dynamic RAM, that is types of RAM. In this video lecture I am going to explain programmable read-only memory, electrically programmable read-only memory, erasable programmable read-only memory. So previous video lecture I have explained what is RAM, differences between RAM and ROM, and then types of RAM and internal structure of memory. So now in this video lecture I am going to explain about read-only memory, ROM. ROM is a permanent storage device. So once the binary pattern is specified by the designer, it is embedded into form interconnection pattern. Once the pattern is established into the chip, then even though the power is turned off, it won't lost the data. That's why this type of memory is called as volatile memory. It can able to hold the data even though the power is turned off. This figure is showing the internal structure of ROM memory. There are n inputs specifying n number 2 power n number of rows. So there are, for example, 4 inputs means 4 zeros. 0 0 0 0 is representing the first location, and all ones, 4 ones, 1 1 1 1 representing the last location. So if n equal to 4, then 2 power 4 rows will be there. 2 power 4 is nothing but 16 rows will be there, and m representing column. So in previous video lecture I have explained the memory structure, internal memory structure, which is consisting of rows and columns. Rows will be specified by address inputs, that is we can call it as a location, and m outputs, data outputs will represented by columns. So for example here we are reading a word, that is byte. Byte means 8 bits, so m equal to 8. So in this row we will have 8 ones or 8 zeros, combination of group of 8 bits, that is 8 columns will be there. For example, if m equal to 8. Next, why it is called as read-only memory means we can able to, user can able to only read the data from the memory. User cannot write into it. That's why it is called as programmable read-only memory. So programmable read-only memory stores such instructions that are required to start a computer. If the power is turned on to the computer, the first program run by the computer is bootstrapping program, that is a basic input output program. So even the power is off, those programs should be stored, and those programs cannot be altered by the user. So OS, operating system programs, will be stored in read-only memory. And read-only memory chips not only designed for computer, we can also use for particular purpose, for example washing machine and microwave oven. So embedded systems like this will be used read-only memory chips. Now types of ROM. Read-only memory classified into programmable read-only memory based upon the programming capability and other capabilities. Erasable programmable read-only memory, electrically erasable programmable read-only memory. So here we will use two types of manufacturing, bipolar and metal oxide semiconductor technology, that is BJTs, transistors or mask transistors. So very first ROM is masked ROM, which is very inexpensive. In your syllabus it is not there. Now we will see what is programmable read-only memory. In read-only memory we can able to take data out of the memory. then we cannot able to enter the data. User cannot able to enter the data. But in programmable read-only memory, user can be modify the data, but only once. User will buys a blank PROM and enters the desired contents using programmable read-only memory program. You can take example like olden days compact disk, that is CD. In CD, once the data is copied, the user cannot alter thereafter. Only once we can able to store the data. So CD is the best example for programmable read-only memory. Coming to erasable programmable read-only memory, it is used in we can able to erase the data at the industry by exposing it into UV light for a duration of 40 minutes. In lab only we can able to erase this one. It will take a long time to erase. If you want to erase even though single group of that is for example, if you want to erase some part of the memory, we have to expose it to ultraviolet. We have to erase entire chip, and then we have to reprogram the entire chip. So next type is electrically erasable and programmable read-only memory. So it can be erased electrically by passing electrical signal high voltage. So both erasing and programming takes place here 4 to 10 milliseconds, and it also erased and programmed about 10,000. As many times we want to erase, we can do. EPROM can be here in electrically erasable PROM can be erased 1 byte at a time rather than erasing entire chip like in erasable programmable read-only memory. Here no need to erase entire chip, we can erase byte by byte. It is more flexible, but it is very slow. Like DVDs. In DVDs, how many times we want to write the data, we can able to write. In pen drive also, if we want to copy the data, we can copy. We can erase the data means we can erase. So next, metal oxide cells. So these are the types of the technologies used for manufacturing purpose of RAM. So the top one is representing mass cells, and bottom one is bipolar cells. So as I explained in previous video lecture, the memory is organized into rows and columns. If there is connection between rows and column here, this is row, this is column. If there is connection, this is the connection between rows and column. If there is a connection, this is representing storing of bit 1. Here there is no connection between rows and column. This is representing bit 0. Here also this is a BJT, bipolar transistor. This is base, this is collector, and this is emitter pin. So you know the transistor consisting of 3 pins. If there is connection between this row and here there is a connection between column, so this is representing it can able to store bit 1, and here there is no connection between row and base of the transistor. So there is it is representing, it is storing bit 0. So like this bits 1s and 0s will be stored in by the transistors in ROM cells. So these are the advantages of RAM. It is a non-volatile in nature. That means even though the power is off, it can able to hold the data. It cannot be accidentally changed, and cheaper than random access memory. So due to high voltage or whatever may be the condition, it cannot be accidentally changed. Easy to test. The testing also done easily. It is more reliable than RAMs. Static and do not require refreshing. Contents are always known, can be verified. So these are the advantages over random access memory. These are the advantages of RAM. And coming to applications, as I told you, this is a permanent memory. So wherever we need to store the data permanently, there we will use read-only memory. So for computer startup programming, that is bootstrap programming, and in embedded systems, once the program is specified, there we will use this RAM chip, read-only memory chip. I hope you understood what is RAM, types of RAM. Thank you.